Hey everybody, my name is Luis Varela-Rico and I'm a metal artist in Las Vegas. This is my first YouTube video, and believe it or not, this is actually not going to be about art. It's going to be about repairing my 100-ton press brake. So basically all this machine does is fold sheet metal, varying thicknesses depending on the die that you have installed on the machine. I was getting a sound from this rocker assembly. I've had inconsistencies from the left to the right side of the machine. After a lot of troubleshooting, we found out that we had a bad bearing. This is actually the bearing that we've taken out already and replaced. This surface should be completely polished, and the reason it's all gouged is because it should also have a Teflon liner that rides in between this piece and this piece. But since it had been worn out, it eventually just started going metal on metal, and it also allowed this bearing to move quite a bit, with probably about an 1/8 inch discrepancy. And what ended up happening is that 1/8 inch discrepancy in the bearing showed up in the part. So sometimes the machine would bend a perfect 90 on this side of the machine, and other times it would underbend or overbend depending on the situation. Here's the rocker assembly, and here's the bearing, and here's the pin that we had to pull out. And that's what we're going to show you in this video today. All right, so here we go. You can see us setting up a couple of A-frames, and we're setting these up over the top of our load being the top portion of the press brake. It's known as the ram. I was able to calculate its weight by figuring out the surface area of the part and multiplying it by its thickness. I was also able to cross-reference some information that I found online, and it all jived, so I made sure that I had plenty of redundancy in my rig. I think I was at least double the capacity of what I needed. I would have liked to use chain falls, but I was borrowing a lot of this equipment, so beggars couldn't be choosers. Once we did get everything set up and we got a little bit of a pick on the ram, we were able to pull the pins from the rocker assembly, and it's always critical to have a pick on something you're getting ready to disassemble, so that way once the pins are actually pulled out, you have full control. Once we had the ram down on the ground, we were able to pull back the rocker assembly. That allowed us to access and put eyes on the bearings that we were trying to remove. Once we got to that point, I did a little bit of designing on CAD, and I kind of just came up with a puller that utilized a 10-ton bottle jack as the pulling or pushing force to remove bearing. Little did I know it was going to take way more force than that, and you'll see in the video we started with that and quickly realized we were going to have to get more power on there. So we started with the 10-ton, that didn't do it, so I actually ended up using a 20-ton bottle jack. I made a completely different puller for that. That didn't work. So then I said, well, the only option we have now is to go borrow another 20-ton bottle jack. And I made this really simple T-style extractor, for lack of a better term. And 40 tons of force finally were able to pull that pin out of its home. It was really satisfying, especially because you're not going to see this in the video, but it took us about a day and a half to get to that point. I was really starting to get worried I was going to have to call in some specialists to do this. As you can imagine, as we were getting these things pulled out and I was witnessing how much force was required to pull these pins out, I was thinking to myself, how are we going to get these back in? And I gotta be honest, I didn't really have that solid of a plan at this point. I knew that we still needed to pull the bearings, so I was just kind of, taking every little success in stride and just waiting for the next problem, and then, you know, trying to come up with solutions. At this point, I thought we had kind of gotten to the hardest part in getting these pins out that had been in there probably since the machine had been originally assembled back at the factory. I gotta be honest, every step of the way was a challenge. While doing all this, I had to make sure that Viv and I were gonna stay safe. We had to watch pinch points. We had to make sure, you know, that no one was gonna lose a finger or an arm or, you know, just the whole thing. So it was pretty stressful. It just kept giving, and the next step was to pull those bearings, and they took more than 10 tons, but we were able to use the 10-ton puller that we had originally made in conjunction with a little bit of tapping with a 4-pound hammer. I know that's not ideal, but we were able to extract the bearings without marring the races, and yeah, it wasn't too bad after all. So when you're working on bearings that have a really tight fit, also known as a negative fit, you're going to have to use some sort of temperature manipulation on the receiving part or on the part that's being inserted to try to get you just that extra little bit of space to be able to slide the part in easier. This was never going to just slide in and drop in. I believe these things are machined to what's called a negative fit. And what that basically means is that the hole diameter that you're trying to slide the part in is smaller. You're solely depending on using temperature. In this case, I ended up freezing the bearing to bring it down very slightly, just so you could get the part into the race, into its home. I decided just to freeze it and try it. I think I lost a couple thousandths, which ultimately ended up being enough. So at this point, I kind of felt like we were at the halfway mark. We had gotten everything disassembled we needed to. We were able to extract the old bearings. We found the problem bearing. We had pressed in the new bearings. So now it was kind of just time to put it all back together. So now we're really close to the end. We need to replace these pins, and we need to grab that ram and pick it back up and do the final assembly of the machine. But these pins were not going to go in easy at all. They required 40 tons to extract them, so it was easy to assume that I was going to need 40 tons to reinsert them. All the tools that we had made up to this point were for pulling, so they were pretty much useless. So I had to go back to the drawing board. I used SketchUp exclusively as the CAD program. A pretty simple solution which allowed me to use two 20-ton bottle jacks to push against the pin. That device was made up of two exact same kind of chain link looking things that I cut on my plasma. Basically boxed those two pieces of steel together. The pushing tool allowed us to pretty efficiently push the pins back in their homes. We did one, we did the other side, and then we moved on to replacing the ram, which was pretty much the last thing. So Hypertherm was nice enough to send me some of their new sink consumables, and it basically consists of these two items here, your tip, and this is an adapter for anyone using the old PowerMax equipment. And what that does is it replaces all of these parts. This is the old style consumable stack with just these two, which simplifies a lot of things because any of these could go bad, and if you don't change them all or make sure that they're all in good working order, you can start to get variables in cutting quality from each individual part. So this makes it a lot simpler. It takes away all the variables. You just, when you start having an issue, you replace the entire tip. All right, everybody, I hope you enjoyed the video. I hope that wasn't overwhelming and there wasn't too much information that you couldn't understand. I want to thank Viv, who you saw in the video, helping me out. She now lives in Washington. What's up, Viv? I hope you're enjoying the weather. My man Keen behind the camera, who shot all this for me, and also Hypertherm, who sent me some of their new sink tips to use on my plasma. So in the next video, we're going to be doing some artwork, some design work, and we're going to be utilizing the machine that we just fixed. So see you next time. Keep the dream alive.